Szanowni Państwo, witam po przerwie. Mam nadzieję, że lunchik bardzo Wam smakował, a mamy na deser smakowity kąsek od Mariana Jureczko. Marian to programista Java z kilkunastoletnim doświadczeniem i pasjonat tematów związanych z jakością oprogramowania. Współtwórca narzędzia Test Arranger oraz autor szeregu artykułów dotyczących testowania. Od ponad 6 lat w Ocado Technology. Przed Państwem Marian Jureczko.
Thank you, and sorry for the technical difficulties and the delay. I'm going to tell you about a tool and approach that saves a lot of time in the test that usually is wasted in the test maintenance. Have you ever been in such situation that a change in the production code results in a number of failing tests? Maybe even some of them do not compile anymore. I see here many experienced engineers, so I believe that you know what I'm talking about. And those who were lucky or skilled enough to avoid such situation can find this talk useful as a guidance showing how to stay on the bright side and never struggle with the failing test. Well, almost never. Anyway, I'm not a member of the lucky group. I was working in a project where we've got very high test maintenance costs of the unit and integration tests. But fortunately, my teammates were skilled engineers, and together we developed a solution that worked really well in that project, and that is a good fit in practically every project I was working on since then. The main part of this talk is a live coding, but before I will jump to the code, let me start with an analogy borrowed from the domain of physics. The equation, that's the second law of thermodynamics. It says that in an isolated system, the entropy can only grow. That means in order to decrease the entropy, we need to do some work on the system. We need to deliver some energy to the system. The entropy we can understand as the measurement of chaos. So when our system is isolated, it will become over time more and more chaotic. And what it has to do with tests? Our tests, when new, usually look very well. It's easy to reason about the test intention, about how the test works, just by reading the test body. But over the time, when new requirements pop up, when new changes are applied in the production code, the tests deteriorate. They are becoming worse and worse. And what we can do about it? The second law of thermodynamics says us we need to deliver some energy. We can deliver the energy in the form of refactorization. Yeah, but refactorization is our own intellectual work, and work can be really exhausting. So is there anything else we can do? Anything less starring? I will try to show you an alternative, which in my opinion is much better. So I will jump now to the code. I've got here some tests copied from a real project. That's the project where we used Test Arranger for the first time. But it's not an exact copy. I copied those tests and somehow I devastated them. I removed the Test Arranger and instead I used production code constructors to instantiate all the test data the test requires. But let's take a look at our test. It's pretty long. Sorry. It's called update tags, and the tags is an overloaded term in our domain. It can represent shopping aisles, which for some fancy reasons are called categories. It can represent filters, which are used by the customer when he is searching for a product in the web shop. And finally, they can represent what we intuitively understood as tags. Yeah, and the test itself, it's pretty long. But the then section is a one-liner. We've got here only one assertion. And the assertion is not made on any magic value like the 1, 2, 3 we've got here. It's over an object that is created within the test. But the biggest issue in the test is in the given section where we've got all those constructors. So let's try to generate the data using test arranger. Test arranger has so method that instantiates objects of the type given to the SOW method as a parameter. So it uses reflection to visit the class. It visits each field, and each field of the class is initialized with a random value. Yeah, and let's do the same with the noisiest constructor of our product, which is really huge. Yeah. And the last one. Yeah, and what's the result? The test is being executed, and in the meantime, we can notice that 3 variables are now in gray. That means dead code. We do not use them anymore. Before, they were used as the product constructor parameters, but right now, we do not call the constructor. It is instantiated using reflection, so we can get rid of those 3 variables. And the test is simplified to 4 lines. Looks much nicer than before. We can now easily notice that the tags the test is interested in are categories. So the first of those 3 possible meanings of tags. So I can also update the name. It went quite smoothly, so let's try to apply the same approach to the second test. This one is about updating price. And here we've got also the huge product constructor. So let's try to remove it. And the same with the price. Yeah, and what's the result? The test is running, and this time in red. And we've got here an error message, unknown retail price unit of measure, and a random string. I just introduced the randomness into the test, so that's presumably my fault. So let's make a step back and check what we had here before. Here is the unit of measure, and it equals each. But notice that the each doesn't appear in any other line of the test. So does it really need to be there, or it's just a coincidence? Hard to say, but without the each, the test fails. So let's check also the production code. Here we've got a Kotlin switch case over the unit of measure. So we see here that the unit of measure can be equal each or kilogram. Otherwise, we've got an exception. So we just find out an invariant of our domain. For some reason, the unit of measure wasn't modeled as an enumeration, but as string. Nonetheless, there are strict requirements regarding the possible values of the unit of measure. It can be only each or kilogram. So how can we tell the test arranger that this one shouldn't be completely random? Fortunately, there is a solution. It's custom arrange. Oh, sorry. Oh. Sorry. So it's custom arranger. So I will try to do it manually, as the shortcut doesn't work for some reasons. Yeah, so I will create a new class in the tests. Oh. And that will be an arranger. And it should extend, sorry, that's Kotlin. Should extend the custom arranger class, and we should give here the type the custom arranger will be responsible for. Oh. It's much easier when IntelliJ helps me. Okay, we also need here to override the instance method. By default, the instance method creates a completely random instance, but we don't need a completely random one. We need some certain values for the unit of measure field. It can be each or kilogram, but of course not the whole list of them, but only one from the list. The sum from is another function from test arranger. It randomly picks up an item from a collection. So let's go back to the test now. We can restore the random solution. And what's the outcome? The test is being, oh, I done here something wrong. So again, the execution. Okay, it's green. But let's stop here for a moment to find out what happened in the test. We are creating here a random instance of the price, but it's not the retail price with the unit of measure. We've got some invariance on. So when test arranger creates instance of the price, it uses a reflection to visit each field, and it creates a random value for this field, a random value for this field. But when it reaches the retail price, it finds out that there on the class path, there is a recipe saying how the retail price should be constructed, and that's our arranger. So instead of creating a completely random one, test arranger calls the instance method from our arranger, and the result of the instance method is assigned to the retail price. So as a consequence, we've got an instance of the price with the well-defined retail price respecting our domain invariance. So it is a good thing to separate those two things. I'm strongly convinced that it is a good thing. The update price test is right now very readable. We can just go line by line, and what we get is something like test specification. Yeah? Get some product, get some price, apply the price on the product, and check that the product currently has the new price. Very simple. The thing that we've got in the arranger is something we need to deliver in order to satisfy our domain requirements. It's not tested in this test. The test only requires that the domain requirements are satisfied. So for the sake of the test readability, it's good to have it separated. On the other hand, whenever we've got another test case which requires the retail price, test arranger automatically will pick up this custom arranger and will create for us a retail price that's in line with our domain invariance. So again, that will be automatically used in every other use case that requires this type without writing any additional code. Okay, another interesting test should be this one. This one is about updating catalog product. Catalog product is a product that is good enough to be included in the web shop. So it needs to meet a number of requirements. Long story short, it needs to be sexy enough that somebody will be willing to buy it. And indeed, within the test, when creating the product, we are setting a number of fields here. But it's not clear if we need all of them, which of them are relevant for catalog product, which of them are relevant for this particular test. So how to simplify that? Again, the arranger comes to rescue. We've got here catalog product method that creates catalogs product. There is no magic involved. That's an ordinary method, ordinary function that just creates the product and sets all the fields that are required for a catalog product. The nice thing about it is that we've got a place, that's the product arranger, where we can store all our methods all our factory methods that are responsible for creating products. So whenever we need a product in our test, we always know where to look for the methods that can help us. And if we don't find a method that meet our needs in the product arranger, then we can be pretty sure that there is no in the whole project, and we can create a one without risking code duplication. Yeah, but that's enough for the test. Let's try it out. No, again, the test is in red. It expects the product status to be ranged, but to be ready to range, but it is ranged. We can find a clue about the error in the test name when shop is missing. I already said the catalog product is a product that is presented in the web shop. So how the shop can be missing? It doesn't add up, and it shouldn't. Yeah? The test is about verifying invalid catalog products. So when the product is invalid, its status will be changed. It won't be anymore the ranged product. It will be ready to range. So we need to degenerate the product by removing the shop assignment. Yeah, so shop, sorry, not shop, but copy, and the shop should be null. Okay. The given section looks this way purposefully. The catalog product is our baseline. That's a concept that's well defined in our domain. Everybody who works on the project knows what is catalog project, what feature it should have, more or less. So we are referring to the baseline, which is a common knowledge of people involved in the project, and saying for this particular test how we need to change the baseline. In our case, we need to remove the shop assignment. If there are still doubts, if that's clear enough, we can add here an assertion showing what's crucial for the test. So in our case, that's product status, and it should be equal ranged, as that's the status the catalog product has. That's, of course, only a commentary explaining what happened in the given section. The real assertion is in the then section. Okay, let's try to fix one more test. This one is about updating product, and we've got here a product, we've got here the data structure that represents the update, and we've got here a group of products. So we've got three objects that are in a kind of relation with each other. So how should we approach such challenge? I suggest to create a fixture for that. So let's create products fixture. That could be Kotlin data class. And it should be responsible for the product, which can be a random one. I need import. And it should be responsible for a group, which also could be random. There is one more body, the data structure representing update, but I will handle it more dynamically using a method. It will be also random, but not completely random, as it needs to be in a relation with the product. So the ID should equal product SKU number. Okay, and back to the test. So we need here an instance of the fixture. And now we can, instead of calling those long constructors, take data from the fixture. So the product. Oh. The same with the group. and the data structure for updates. And let's check what's the result. Again, it wasn't so quick. The error is in this line. It complains about tobacco. So without boring you to death with the domain details, I will say right away, it's about selling restrictions. Not everybody can buy tobacco. So we need some additional logic in the fixture. But in the fixture, there is a lot of place for logic constructing our objects, so it's not a problem. So let's set here the restriction. It can be delivered here as a method parameter. And we need to set the parameter in our test. The restriction code for tobacco is this one. So that should solve the case. Yeah, it's green. So we did it, we simplified another test. We can also clean up a bit this one. We are using here shop calling fetch for no particular reason. That presumably should be the shop that was generated for our product, otherwise it doesn't make much sense. And now we can inline some of the variables. The shop, the group, and the product. And the huge given section that's currently only 2 lines. Of course, something is in the fixture, yeah, but the test look really nice now. That was the last test I wanted to show you. But now I'd like to show you all the changes as a summary of everything what happened during the live coding. So the easiest thing to notice is in the given section. The given section were huge. Now they are small. Yeah, in this case, only 2 lines. But the benefit doesn't regard only the number of removed lines. We also loosened the coupling with our production code. Before, we were calling here constructors. So whenever the entity or data transfer object that's behind the constructor is changing, the signature of the constructor is changing, and we need to adjust our test. So every change in the almost every change in the production code results in test maintenance. Right now, we are using reflection. So the signature of the production classes might change without affecting our test, as long as the test object won't be changed in the production code. We see similar benefits in the update price test, but here we also had the arranger, which was a place where we can store our domain invariants so that they are used in money test whenever they are needed. And the arranger is also a place where we can store all our factory methods responsible for creating a certain type. In this case, it would be the retail price. When we need more complex data structure, where several objects are in some relation with each another, then we may have the fixture. There is one more nice thing I'd like to show you, which is not test arranger feature, but rather something that Kotlin gives us. It was in the product arranger, and it's about the shop parameter. Please note that this parameter is optional. It is initialized with a random value. We may have here more similar parameters. We may have here the range date, also with some random value and some other parameters. Yeah. When the parameters have default value, they are optional. So we can call the catalog product method without giving them. But when we need to have a certain shop, then we set the shop, and we can ignore the rest. When we need the shop and the range dates, we can set both the shop and the range dates, ignore the rest. When we need the other parameter, we set only the other and ignore the rest. So we've got only one method or one function in our code, but we can handle a great variety of different scenarios. Nice, isn't it? If we would like to accomplish the same in Java, we would need a dedicated method for each combination of parameters that's being used. A lot of boilerplate code. Okay, so let's go back to the presentation. Have we overcome the second law of thermodynamics? Well, unfortunately, it's not so easy to beat the physics. Our entropy still can only grow. What we managed to do is to narrow the size, the scope of our system, of our tests. So right now there is less code, and the entropy will be growing slower. Our test will degenerate slower, and when we will be forced to deliver some energy in the form of refactorization, it will be definitely less energy. So it should work pretty well for us and save us a lot of time. In a moment, I will ask you for comments and questions, but before I give you the floor, let me give you some references to the solution. The test arranger is open sourced. It's available on the Apache license. There is a GitHub page of the project. The test arranger binaries are available in Maven Central, so it's enough to add dependencies to your project to try it out. I'd like also to encourage you to visit the GitHub page, as there are much more details about the tool and the whole solutions. As a preview, I'd like to show you this diagram, as it also very well summarizes the content I presented during live coding. So we've got here the SOM method, which was there to create instances of certain types. We've got here the arranger, which was the place for storing domain invariants, as well as the place for factory methods for a certain type. And we've got here the fixture, which is responsible for creating constellations of objects that are in relation with each other. Formally speaking, the arranger is an implementation of the fixture design pattern. However, I purposefully distinguish between those two because it's a typical case that in a software project you will have a number of the arrangers, a great number of arrangers, but each of them has very strict, well-defined responsibility. So it's easy to find the right one because they are always creating the same type. On the other hand, you will probably have only few fixtures, only several such classes. So despite they have not such precisely defined responsibilities, it will be quite easy to find them because there will be only several such classes. So the whole should be manageable. I'd like to encourage you to give it a try. It won't be a wasted time, I promise. Thank you very much for your attention.
I can see already a hand in the air.
We actually use test data builders in our project, and it works in similar way. We have all the fields defined with a random number or just null if possible, and we use similar data. If you need to test, for example, let it be some car, you have to have just a car. You do the same. Create me a car. Bang, here we are. If you need to check its model, then you can provide the model, override the random value. And we store all these the data builders in separate classes. So do we really get something easier using your test arranger?
What you described is very similar to what I'm advocating. Well, I must admit, that that's not a great invention. We picked up many solutions that were available on the market already and packed it into a combined solution, and do the synergy. We've got some extra benefits. I believe that in the difference between your solutions and mine, is that you need those builders for test code. I don't need them, yeah, so it's the layer of code I can avoid. And the builders create a tight coupling with the production code, yeah, they are calling the production factory methods. That could be constructors like in my live coding, but that can be also different kinds of methods. Yeah? At the beginning, I mentioned, yeah, that there are better ways for creating test data than constructors. Yeah, your way is definitely better. Yeah, but usually the better ways, like the classic fixture design patterns, work in such a way that the coupling between production code and test code is moved to a single place. Yeah? So when the production code is changed, you have only the single place to change, yeah? Not hundreds of tests that just start failing. Yeah, maybe they just start failing because the one place is not adjusted, yeah? But you all have only one place to adjust. Yeah? And with the reflection and random data, we managed to remove the one single place. Yeah? So you are on good path, but you can still have a little gain.
Thank you very much.
That was an excellent question. Who'd like to go next? The live coding part was fire. Thank you very much, Marian. A round of applause.